All right, good morning, guys. Let me talk about the calendar for a second. Yeah. Today we're going to cover law of cosines. Algebraically, it's a little messy, but it's easier than the ambiguous case that we did with law of sines. Okay, so we'll practice that today. Tomorrow we'll do a review worksheet, which is in your packet. And then Monday we'll do review, and Tuesday will be a quiz over law of sines and law of cosines. So it'll cover what you did on the check-in quiz, the ambiguous case, and law of cosines. Okay. Now I gave you this this little handout on the half sheet as a way of kind of give you an overview as to all the possibilities that we're dealing with. Okay, so just kind of to give you an overview here, depending on the information that's provided for you in the triangle, that's going to help guide how you're going to move through the problem. So the easiest ones are ones where they give you two angles. If it's either angle, side, angle, or angle, angle, side, these are the easiest. These are the ones that you can handle with law of sines. You guys did it. Majority of you did very well on the check-in quiz, where you just find a missing angle and then you just pair up your missing side or missing angle, and then you use law of sines and you find the missing sides and you solve the triangle. So when you're dealing with, if you see two angles in your triangle, you know you're dealing with the easier problem. Okay, those are not difficult. Now, the ones that are more challenging are the ones that are like side, side, angle, where you are given an angle, side, side. And with this situation, we know that there's this hanging side, right? The hanging side that really, we really need some foundation to know what to do with that hanging side. So we have to go through and find that altitude, right? Find that, that imaginary height for a right triangle. And that imaginary height is going to tell us what to do with that 10. Is that 10 going to be long enough to arrive and create a right angle? Or is it too long where it's going to have to stay out here and form an acute triangle? Or is it longer than the height, but shorter than the hypotenuse, which means that it can swing back and forth between an acute triangle and an obtuse triangle? And that's a situation where we got to create two triangles, and there's a whole mess. But we practiced with that, and we'll get some more practice today and tomorrow and Monday. Okay. So today we're talking about triangles where they give you side, angle, side, and side, side, side. These are the ones where you're going to start with law of cosines, because law of cosines is going to help you get the missing piece that you need to then allow you to arrive at a point where you can finish off the law of cosines, sorry, law of sines. So law of cosines allows you to handle these particular triangles. So side, angle, side is a situation where you're not going to be able to start off with law of sines. You're going to have to start with law of cosines, or side, side, side. But I want to make sure that, do you see the distinction between side, angle, side and side, side, angle? So side, angle, side is where your angle is sandwiched between two known sides. Here, side, side, angle is where your angle is not between two known sides. And that's where you got to go through that ambiguous case test out. But if you see a side, angle, side where the angle is nicely between two known sides, it's a pretty straightforward law of cosines problem. And side, side, side is easy, where they only give you three sides, and you have to go from there. So today we're just focusing on what to do when we see these types of triangles given to us. Okay.
That's right.
Yes.
It was at the sheet. I don't think you gave it to.
Oh, yes. Here.
Oh, my bad.
Anyone else? You know? Okay, so let's go to our packet. Let's go to our packet and let's go to page 12. Sorry, page 10. Okay. I'm gonna skip the proofs portion of it and just move directly to the application. So here's the law of cosines halfway down your page. Law of cosines allows us to solve for oblique. Oblique are non-right triangles. When we have either 3 side lengths given or 2 side lengths and include angle. If your angle is sandwiched between 2 sides, we call that side angle side. So let's look at number 1 here. You got angle A, side B, and side C. So if you create your triangle, anyway, it doesn't have to be in this orientation, but if you fill out your triangle, you can see that side C and side B allows us to create that side angle side, which means that we're going to follow we're going to start off with law of cosines to get this, to get that missing piece that we need. And then usually we finish off a problem once we have enough information with law of sines. We can do everything with law of cosines, but typically law of cosines is a little bit more cumbersome. So typically students, once they can get to a point where they can transfer hand over to law of sines, typically students prefer that because it's a little bit easier to work with law of sines. Okay, but side angle side, we're forced to have to go through law of cosines. So this is how you start it. You start off by putting the box around the angle. And that is going to help you decide which formula to use. You want to use the formula that has angle A in it. So which one do we choose? First, second, or third? Third one. Okay, so third one, we're gonna let that angle, whatever is the known angle is what we're gonna gravitate towards. So here's our formula then. A squared equals, sorry, 1 second. Now, my preference, especially if you're using your calculator, is to ensure that your calculator is doing the order of operations that you want it to. I like to put a parentheses around that 2bc cosine A, just so that it ensures that the calculator is not trying to subtract something before it multiplies everything else. So we want all this to be taken care of before it gets subtracted. So having that extra set of parentheses just ensures that the calculator is not doing the order of operations out of order for us. Okay, so the nice thing about side angle side is everything is ready for you to plug in. So you have B, you have your C, you have your 2bc, you have your cosine A, and everything just goes on the right side of your formula. B squared. Make sure you're in degree mode. To start entering all this into your calculator. So what happens after this? We still got to take the what? Square root. Now, this is my preference. If you do square root, if you do second negative sign, it'll pull the previous entry, and that way your calculator will be as accurate as possible because it's taking everything from previous entry, and rather than you rounding to 3 decimal places and then getting the square root, it's more accurate if you do it this way. Does that make sense? So if you do if you do square root of answer, you can pull that by doing second negative. It'll give you just slightly more accurate reading. And then you can round to 3 decimal places at the end. So 16.492 is your A value. Yes, question.
So like on the quiz, if we like forget to do that, we want to quarter off points for it.
Probably not. But it just allows you to ensure that you can get as accurate a reading as possible. Right? So if you have your calculator, right, take advantage of that feature, and that way, and imagine if you're a decimal off and you're doing other operations, it'll just continually get more and more inaccurate. Does that make sense? So, yeah, especially halfway through the problem, you want to try to improve the accuracy, because if you're inaccurate halfway through, it's going to be even more inaccurate at the end, and then that could lead to an answer that's completely off, and then that will take points off. Any questions at this point? So usually, as soon as you apply law of cosines once, your problem is ready to be transferred over to law of sines to finish off the rest. So what information am I still missing from this triangle? Yep, angle B and angle C, right? So I can do law of sines once, right? I can pair up angle A and side A, and then either solve for angle C or angle B. Doesn't matter which one. But as soon as I find one of the angles, I can use 180 minus the other two angles to get my missing angle, right? So law of cosine once, law of sine once, and then we should be at the end. Okay. But I'm going to solve for sine. I'm going to solve for B, but you can solve for C if you want. So I'll do A over sine A equals B over sine B. Cross multiply, get sine B by itself, and then do inverse sine to get angle B. If you can find angle B, then angle C is easy because you can just subtract the other two angles from 180 to get angle C. Just gonna say from now on, We're gonna just round to 3 decimal places. Okay, that way, we try to be on the same page there.
When dividing like the 23 sine 45 divided by 16.472, should you purposely the sine 45 for the 23?
Say it again?
Should you purposely the sine 45 for the 23 when you divide that equation by 16.492?
Yeah, so I do 23 times sine 45 divided by 16.4.
Yeah, what do you parentheses the sine 45? Like,
I think the calculator, let me see, does it do it for you? Yeah, I think it just naturally creates a parentheses for you, so just go ahead and close that parentheses. But if you write it out, you don't have to have parentheses. You understand that 45 is inside the sign. The calculator kind of does have that parentheses there. Good. Any questions with side angle sine, law of cosines? Okay, let's look at page 11. So what type of triangle do we have here? This side, okay. So side, you're also going to apply using law of cosines, but it's a little messier algebraically because you're not going to be able to, it's not going to be as clean. You have to kind of do some adding, subtracting, dividing a little bit more than before. And the target here is you want to start with the longest side or find the largest angle. And the largest angle is going to be opposite the longest side. And the reason that you do this is because if you don't, you may run into an issue later when you do law of sines, where it's going to give you 2 angle measures and it just could cause issues. So if we always start with the largest angle, we're just not going to run into that potential issue of 2 solutions. So if you're dealing with a side, okay, start with the largest angle. And the largest angle is always going to be across the longest side. So what's the longest side? Okay, so therefore the largest angle must be what? Angle B. So put a box around B, and you want to choose the formula with angle B in it. Everybody good so far? Okay, strategy for side. Start with the largest angle. Okay, so angle B is the second one, so I'm going to copy that formula down. Fill in everything that we know. It's a little messier because now we have to kind of move things away from that cosine B until eventually we can do inverse cosine and solve for angle B. But we're gonna have to clean this up, subtract the 19 squared over, subtract the 21 squared over, and then divide this whole decimal value over as well. Okay, so one piece at a time. So I start off by just taking care of these 3, putting them all together, moving it to one side. Okay, divide both sides by negative 828. And now I want to solve for angle B, so do inverse cosine. As soon as you apply law of cosines once, you should be able to hand this problem over to law of sines to finish off the test.
Is it 72? Oh, yeah, there's.
Yeah, 72.743. Now I can use law of sines to finish off the rest, right? I can pair up angle B side B and either solve for angle A or angle C. Okay. I'm going to solve for angle A, but you can choose whichever one you want to do. Questions? Yeah, question.
You use cosine and then the things at the bottom you use sine.
Yeah, you if you start off with side, you use law of cosines to get that one missing piece that you need. And then once you can get that one missing piece, then the rest of the problem you can use law of sines.
Okay.
Yeah. Now you're welcome to do law of cosines for other angles as well, but typically students prefer not to do that. You usually want to do law of cosines if you absolutely have to. And law of sines typically is the easier one to do.
The little decimals are off, is that okay?
How much off are you?
Like 926.926.
That's pretty off.
Okay.
So check again, see if, because your angle A should be close to mine. Yeah, so as soon as you get this decimal, rather than typing in this decimal, do like second sign of second answer, and that will, it will just pull it out.
Okay.
Now, obviously, if your work is correct, you still earn the majority of the points, but if you're off, then I may take off a point. But it's not as important as all the rest of the steps that you're doing. Okay, let's look at number 3. Okay, how would you start number 3? Good, angle C. So find the formula for angle C, and then just repeat the same steps that you did for number 2. Okay, I'll walk around, see how you guys do. And today we're just gonna try to focus on law of cosines, get really comfortable with it. And then tomorrow we can put, you know, the law of sines problems. It's the ambiguous case. That's the one that's the messiest. We'll spend some time doing that tomorrow, but if we can just get law of cosines down today, we can spend tomorrow and Monday reviewing and plays on Tuesday. Remember, uppercase always refers to angle measure, lowercase always refers to side. Guys, if you get done with number 3, our classwork is going to be page 12, numbers 1 and 2. Just to get that additional practice, you'll see a side angle side and a side side side. That way, I know that you're good. Or we can put it all together. Get done with number 3, go to page 12. We're going to just do numbers 1 and 2. All signs for this. I'll put the answers up in this. Okay, any questions?
What do we do after?
Yeah, so after this, we're gonna go to page 12. And then we're just gonna do one and two. If you feel like you don't have enough room, you can use the half sheet that I gave you, use it back, or you can come up and grab another scratch sheet if you like. We're just gonna practice more law of cosines, okay?
Did you skip the between like the 24 squared and like the 134?
So what I did here was I did 24 squared, minus 9 squared, minus 19 squared, and I gave you.
So you separate it, you isolate it from the paper.
That's right, yeah, I isolated it so that I can divide this over and eventually get that cosine C. So,
You do like inverse of cosine of 134 over negative.
exactly, yeah,
I asked you something else.
you did. Okay, let me try again. Oh, wait. This,
Yeah, here's the.
But that doesn't.
I want to wait.
Yeah, I'm assuming.
I feel like it's actually like. That's what I'm-
So it's 130.
Negative 340. 340. Oh, 340, right, sorry. Yeah, that, and then you take the inverse.
Yeah,
Yeah, so sorry.
so look, you got 0.310.
Yeah, I just wrote off the whole decimal.
It's not the same.
Negative.
But it's interesting.
so when I divided 134 by negative 342, I got negative 0.39181.
That's
And I
what
did inverse cosine of that, and then I got 113.
Yeah, like.
But I took the inverse of that too. I got some items.
I did it like, divided by that.
Wait.
It's like.
What's you get? Wait, hold on. I think I can work this.
Remember, 134 divided by negative 342.
I did 430. Oh, it has to be negative. Yeah, negative 432 though, right? Or unless it's the wrong number.
Yeah, make sure you divide by negative
Hold on.
342. If you don't, you're gonna get to the number.
I have it all in. I together by dividing that.
Well, Grant, are you in the green line?
Well, I don't know.
I got it.
Put it zero.
I got it.
I know, it's out.
Grant, are you in the green?
Yeah, so what I did was,
No, it's still, it's still doing next
Two
year.
times 9
Look at
times 24.
Now,
it's like, it's like.
Wait, how many? 340.
that's what it is.
But I'm getting 432.
9 squared was
Can't be
19.
four. No, not that.
Oh, wait.
Not that part, not that part.
19.
2 times 9
It's one-
times 24. 9 times 24. Times 432.
Are you in green? Or degree?
3.
What is it? I can do cos -1.
Oh, you just click on it, it's like.
You could, yeah. you could put that.
that's fine. Yeah, good.
I see what I did.
Where?
No.
6.
Make sure you're in degree mode.
I see what I did. I put 24. Oh, as a C value instead of. 19.
Because every time that I've done it. And I'm with you.
Negative. I wouldn't like to do it.
You only want to find out one?
Let me see.
Yes, that one.
Like, it wasn't a good thing.
Wait, now I should get the things.
If there's any questions with 3, let me know so I can help you. I want to make sure everyone is. These steps.
Looking minus or this? I'm pretty.
Okay, go ahead and try 1 and 2 on page 12.
I think you were. It's.
Okay. Still looking at it.
Did you get it?
I have another question. So I did it wrong and I got signed 66.933 and I solved for A and I still got the same answer as you.
How did you get this?
I somehow did it wrong. I did that.
Yeah, then you're running a risk. You divide by negative. Because I facts. Yeah. Negative 372 over. And carry that negative over. So dividing by positive. Backtrack things. So I think it must be something. 0.3.
But how did I get the same answer for?
Because it gave you a supplementary angle, which can still have a chance of getting that angle.
Oh,
But it's hit or miss, right? Sometimes different, it may not guarantee to always get it.
okay. Yes, okay.
Yeah, let me pull. Let me just show the answers for 1 and 2 for those of you who want to check your answers, but I can work through them in detail as well. So number 1 is a side and equal side. Two is side, so probably we'll see.
The angle that's the biggest will have like the largest corresponding side, right?
Say it again?
The angle that's the largest will have like largest corresponding side.
That's right, Yes.
Why do we are coupled like decimals? Answer, but just come up with.
How far off are you?
Like it's 197 out of 187.
Yeah, that's right at that edge where I'll probably give you credit, because you're close enough, but if you can hold on to your, decimal value a little longer or increase, if you're halfway through the problem, try to go to 4 decimal places, possibly. No.
Oh, yeah. Watching for what was that?
Yeah, the sine and cosine graphs.
Yeah.
When you were doing the real thing.
That's pretty what?
It felt like it was actually.
Like here, they only give you angle.
There's no-
It's like engineers out there.
Yeah.
It's a lot of engineering.
Yeah, so I'm gonna start with angle A. That's your formula. Yeah.
Answer. And let's see if the opposite is.
Is that right answer though?
I got like. I got 193.
That's fine.
If you want any difference. Is that you? I didn't
That's fine. Except for.
Oh, I thought it was that's the same.
Yeah, so I'm just switching.
I'm hoping and I'm visualizing and I'm gonna see people that's. It's very, I love.
That's your seminar or?
Places inside. Okay, we're already started.
Okay, so tomorrow, we're gonna try to, we're just reviewing tomorrow, and Monday review and Tuesday quiz. I hope we get the book.
I played to argue. I think it's chapter.